So I think one of the confusing things about work and then adding in the simple machines that we've been talking about is understanding why does increasing the length of the distance decrease force needed in work. I think we get it, mathematically when we look at the when we look at work equals force times distance equation. If this stays a constant, right? If this is going to equal 10, for instance, we can manipulate force and distance to equal 10. Force could be 5 and distance could be 2, or force could be 2 and distance could be 5, right? So mathematically, 5 times 2 or 2 times 5 is the exact same thing. It's always going to equal 10. However, we're assigning 5 or 2 to either force or distance, and it becomes a totally different understanding of work. When we're looking at force is how easy work is. So if we want the work to be easy, we want the force to be small. The distance that we exert that force then will have to be longer. But that still makes it easier. We don't have to apply as much force. We don't have to, in layman's terms, we don't have to work as hard, even though really in scientific terms, we're doing the same amount of work. So I wanted to give you an example kind of through a drawing, and hopefully this will kind of make sense. If this picture is showing us in my backyard, right? Here I am, and I was going to plant a tree in this hole. However, at the bottom of the hole, when I'm digging, I find that there's a big rock, right? It weighs, 200 pounds or something like that. I could go in there and try to grab it from, both sides and lift it up and get it out of the way, but that's going to take a lot of, in layman's terms, work, right? So in order to decrease the amount of force that I'm putting in to make it easier, I'm going to grab my handy dandy lever, right? It's basically just a big metal shaft. So if I've got a big, long lever, right, and I stick it under the rock like that, right? Stick under the rock. And this, then, therefore, the side of the hole right here, that would end up being my fulcrum, right? And as you can see, the fulcrum is a little bit closer to the rock than it is to me, right? If I am the input force, and the middle, therefore, would be right about here. So it would be better if we could either move the fulcrum, right, add some dirt in here, right, make the fulcrum a little bit closer to the rock, or make my lever a little bit longer. So when we're looking at distance traveled, I get to pull the lever all the way down here. This lever, right now, the way this is set up, and obviously this drawing doesn't totally make sense, that would be like a 15, 20-foot lever, but the lever is as tall as I am. So that's almost, that's 5 feet 9 inches. That's very high up. A distance that I would be moving that lever down would be nearly 6 feet, right? About 2 meters that I would be moving that lever down. So I wouldn't have to work very hard, or I wouldn't have to put in much force. It would be pretty easy for me to move that 6 meters. The rock, on the other hand, wouldn't move 6 meters. The distance that it would move, maybe it would flip over right here. It moved half of a meter, but I didn't have to put in all that much force. So then if I did it again and I got it to move another 2 meter, or another half of a meter, then I got it to move another half of a meter. Each time that I did that, each time that I moved that rock half of a meter, I would move the lever 6 feet or 2 meters, right? So what that's telling you is that I'm not having to do or put in all that much force to get this to move a short distance. If I instead wanted to move it a long distance, that would be a whole different issue, right? That would be me having to put in more force. But since we're okay with moving the rock in these short little distances, and I'm moving in this long distance, that means that my force that I'm putting in will be low. This 200-pound rock, that's a heavy rock. That is a lot of force due to gravity, right? When we think about how much something weighs, and weight is force due to gravity, if we're talking about a 200-pound rock that's about 50 kilograms, 50 times 10 for meters per second, we're looking at something that's 500 newtons. So I'm moving a 500 Newton rock 0.5 meters every time that I use my lever here. And after using it 3 times, I get it out of the hole. And every single time, I don't have to apply all that much force, but I am moving it a great distance. I'm choosing to do this one because remember, force is easiness. If instead I had, right, this is option A, right? This is the good option. This is the easy option. Let's say we've got a hole, we've got a rock, and here's me again. And then my lever only goes like that, right? That's my lever now. First thing that should give away that option B is not going to be as easy is that the fulcrum right here is closer to the input. And from my last video and from our notes, we know that as soon as the fulcrum moves closer to the input, me, right, if the input is over here, as soon as the fulcrum moves closer to the input, I'm going to have to apply more force, meaning the mechanical advantage is going to go down. The other way we can tell is that this thing is only going to move, let's say half, if this moved 2 meters, this is only going to move 0.5 meters. Now, if I get this down 0.5 meters, this thing will probably flip all the way over to here, right? We'll move the rock twice as far, but I'm going to have to apply a much greater force. This is harder, right? Because shorter distance, more force from me. This will be over here, a longer distance, less force. But this is not a good option. We want this where I move a long distance with a small force input, right? This rock won't move very far, but I'm going to be moving all of the weight of that rock very easily by moving it a long distance. So option B here is going to be harder. I'm going to have to push down for 0.5 meters. Right? I'm not getting much travel out of my lever, 0.5 meters, and I'm going to have to put a lot of force on that lever to get it to move down at all. Yes, the fulcrum will move more, and maybe the rock will flip a little bit further. However, I will be, sweating and working essentially much harder to achieve the same scientific amount of work. So we always, always, always want option A, which is where we apply the force over a long distance. Because if you're applying the force over a long distance, that means that you are not putting in much force. It's a small amount of force, and therefore you won't feel as though you have worked as hard. It will be a lot easier. So I hope this helps you understand why making the distance a little bit greater on the input side helps make everything all the more easy when you're doing work.